922, multiplying fractions. Next up on our Things Everyone Hates agenda, we have fractions. I'll save you the What Fractions Are lecture, and we'll dive right into reviewing operations. To multiply a set of fractions, we multiply across the top and across the bottom, then simplify whatever's left. For example, here we take 2 multiplied by 5, and we get 10. On the bottom we take 3 multiplied by 6 to get 18. If you left your answer as 10 over 18, though, this would not be correct. The reason for that is that we can simplify this fraction. And how that works is we can divide both of these numbers by the same number. For example, the number 2 goes into both of these numbers. It's a factor of 10 and a factor of 18. So if I divide the top and the bottom by 2, my fraction is actually 5/9. If we look at 5/3 times 5/7, the top gives us 25 and the bottom 21. So if we consider what are some factors of 25, well, 25 times 1, yeah. Other than that, 5 times 5 is the only one that works. Does 5 multiply into 21? No. So therefore, this cannot be simplified. And that's our final answer. What about a problem where we end up with the same number on the top and the bottom of the fraction, like this? 7 times 2 gives us 14, and 2 times 7 also gives us 14. Well, some of you may instantly recognize this is just 1. But how can we get there? If we divide the top by 14 and the bottom by 14, because you have to divide by the same number, we end up with 1 over 1, which is the same thing as 1. So what about when we have variables? Well, everything else works the same. 2 times 10 is 20. Y times 6 is 6y. When I'm trying to simplify this, I only look at the coefficient for the variable here. Because there's no y term on top, there's only a variable on bottom, so therefore I'm simplifying 20 divided by 6. And 2 goes into both of those numbers, so I'm going to divide the top and the bottom by 2, and I end up with 10 over 3y. That's my final answer. So on the back, let's look at a few more types. Here, when we multiply straight across, we end up with a 10x on top and an 18x on bottom. Notice that x divided by x actually cancels out. So we can either draw a line through it or erase it, but these x's disappear because there's 1 on top and 1 on bottom. And x divided by x, well, it would look like this, 10x and 18x, and I divide it by x. And what do I get? 10 times 1, or 18 times 1, which is the same thing as 10 over 18. Now a tip on can these be simplified? Take a look if we have two even numbers. If we do, you can always divide by 2. Here we have two even numbers, so we can divide both by 2, and we end up with 5 over 9. Just a couple more. Here we have 3 fractions, x thirds times y sixths times 1/2. If we multiply straight across the top, we get 1xy. And usually we can just write that as xy. We don't need to put the 1 in front of it. That's how we multiply different variables. We just write them usually in alphabetical order. The bottom, 3 times 6 is 18, times 2 is 36. Can we simplify this? No. That is the final answer. Or what about a problem like this? X over a times y over b times z over c. Well, we put the xyz on top, ABC on bottom, and that's it. We cannot simplify because there are no common terms. These are all different variables, and the coefficient for both of them would be 1. One last problem, the very last one, multiplying 5 fractions at the same time. My advice would be to multiply from left to right. So for example, 4 times 6 is 24, times 1, still 24, times 3 gives you 72, times 1, still 72 on top. Now for the bottom, 5 times 7 is 35, times 5 is 175 times 2 is 350 times 2 is 700. Trying to simplify a fraction like this can be challenging. Let me show you a trick on your calculator. There's a button just below the green alpha button that says Math. If you type into your calculator 72 divided by 700, press enter, you'll get a decimal. If you press Math, enter, enter again, it will convert this automatically to the lowest form possible for the fraction. That's one way to use your calculator to automatically simplify this. A more traditional technique would be look for common factors. Start with the obvious ones. For even numbers, we could divide by 2, and this becomes 36 over 350. We could use that process once or twice more. Dividing by 2 again, since we know they're both even, 18 over 175. Now we're no longer looking at even numbers, so what are some factors of 18? 3 and 6, neither of which go into 175, so that is our final answer.